Hello everyone. I hope you all are fine and doing well. So I'm Poonam Sharma. Welcome you all again another interesting session of metals and non-metals chapter. Children, as I told you, this chapter is extremely important and it carries maximum marks. So just go through this chapter thoroughly. Whatever I'm teaching you, learn it thoroughly. Go through each and every detail. So in previous class, we have discussed about physical properties of non-metals, and I have also discussed difference between metals and non-metals on the basis of their physical properties. Few chemical properties also I have discussed with you in previous class. So I hope those topics are clear to you and you have gone through those topics. If you face any doubt or any problem is there, you can write in the comment box and I'll take your doubt later. So in today's class, I'll start with the chemical properties of non-metals. As I told you, non-metals are entirely different from those of metals. So whatever properties do metals have, the non-metals exactly have opposite properties. Like if we have done in case of physical properties, if you remember, but there are certain exceptions in non-metals. Like there are certain exceptions in metals, so there are certain exceptions in non-metals also, like diamond and graphite, which are the allotropes of carbon. So they are good conductor of electricity, and diamond is known as the hardest substance. And this iodine is lustrous, diamond is lustrous in nature. So these are the exceptions in case of non-metal. So we have discussed these physical properties in previous class. So let's move on to chemical properties of non-metals. Now first property of non-metal is what will happen if non-metals react with oxygen. As we have discussed in metal topic, when metals react with oxygen, they form metallic oxides. So similarly, non-metals, when they react with oxygen, they form non-metallic oxides. As you can see here, when non-metals react with oxygen, it results in the formation of oxides, and which are known as non-metallic oxides. Let's take an example of carbon. As you know, carbon is a non-metal which exists in nature in two forms, diamond and graphite. So when this carbon reacts with oxygen, carbon dioxide gas is formed along with the production of heat. So let's look at the reaction. When carbon reacts with oxygen, it results in the formation of carbon dioxide gas. And when carbon burns in insufficient supply of oxygen, so when we are burning carbon in presence of sufficient supply of oxygen, it forms carbon dioxide. But when the insufficient supply of oxygen is there, in that case it releases a toxic gas which is known as carbon monoxide. And that's the reason why it is always advised that never sleep in a closed room in which coal is burning, because coal is also contains carbon. So when that coal is burning, generally in winters, people use angitis. So in which they'll burn coal to keep their room warm. And when you are using that coal, don't close all the windows and the doors. Because due to the closing of windows and the doors, the supply of oxygen gets cut off. And if there is an insufficient supply of oxygen, so it results in the formation of carbon monoxide gas, which is a toxic substance. And when we inhale this carbon monoxide gas, it has the tendency to combine with hemoglobin at a much faster rate in comparison with the oxygen. So when it combines with the hemoglobin, it forms carboxyhemoglobin. Carboxyhemoglobin, which cut off the supply of oxygen in our blood and will leads to the sometimes death of a person also. So that's why it is always advised that never sleep in a room which is closed, in which you are burning carbon, okay, in the form of coal. Now next is when Carbon reacts with oxygen, as I told you. Okay, now next is when sulfur. Sulfur burns in presence of oxygen, it results in the formation of sulfur dioxide gas. And this sulfur dioxide gas, when reacts with water, it forms acid, which is a result of acidic rain. So this sulfur gives sulfur dioxide gas when reacts with oxygen, and this sulfur catches fire when exposed to oxygen. So it has a tendency to catches fire very easily. When hydrogen reacts with oxygen, it gives water. This is very simple reaction and we all know about it. So here we have done 3 non-metals till now. Carbon reacts with oxygen, it forms carbon dioxide gas. When sulfur reacts with oxygen, it forms sulfur dioxide gas. And when hydrogen reacts with oxygen, it forms water. No gas is released here. Then these non-metallic oxides, which are formed as a result of a reaction between non-metals and oxygen, they are quite acidic in nature. And due to their acidic nature, they turn the blue litmus red. If you remember in acid basis salt chapter, we have done this test. This litmus paper or litmus solution tells or indicates whether the substance is acidic or basic in nature. So if a blue litmus turns into red, it shows that that solution is acidic in nature. And non-metallic oxides, which are formed as a result of a reaction between non-metals and oxygen, they are quite acidic in nature. Look at the examples. As I told you, with carbon dioxide, it gives carbonic acid. So when carbon dioxide reacts with oxygen, this carbon dioxide is a non-metallic oxide, which is formed when the carbon reacts with oxygen. If you remember here, look at this. When carbon reacts with this oxygen, it results in the formation of carbon dioxide. And when this non-metallic oxide reacts with water, it results in the formation of carbonic acid. And this carbonic acid generally we use in carbonated drinks. In like Pepsi, Coke, in all these drinks we use this carbonic acid. Now look at the another example of non-metallic oxide, and this carbonic acid is acidic in nature. Although it is a weak acid, but still it has an acidic property due to the presence of hydrogen ions. Then second is sulfur dioxide. When sulfur dioxide is formed when sulfur reacts with oxygen, and it results in the formation of sulfur dioxide, as you can see here. So when this sulfur dioxide reacts with water or dissolve in water, it results in the formation of sulfuric acid. As you can see this reaction, SO2 plus H2O. So when it combines, so we'll get H2SO3, which is sulfuric acid. Then this sulfur dioxide gives sulfuric acid when reacts with oxygen. So this sulfur dioxide, when again it reacts with oxygen, it forms sulfur trioxide, and when this sulfur trioxide again reacts with water, it forms sulfuric acid. Okay, now how this sulfuric acid is formed? So this sulfuric acid basically it is formed by the sulfur. So when sulfur reacts with oxygen, it forms sulfur dioxide. When that sulfur dioxide again reacts with oxygen, it forms sulfur trioxide. And that sulfur trioxide, when reacts with water, it forms sulfuric acid. So this is how the reaction takes place between sulfur and oxygen. So here we'll get two products like sulfuric acid when sulfur dioxide reacts with water, and when sulfur trioxide reacts with water, it results in the formation of sulfuric acid. Okay. Now reaction of non-metals with chlorine. So when non-metals react with chlorine, it results in the formation of non-metal chloride. Although chlorine is also non-metal. Now, so hydrogen gas is liberated. So when hydrogen reacts with chlorine, it results in the formation of this hydrochloric acid, and when phosphorus reacts with chlorine, it results in the phosphorus trichloride. So these are the reactions of non-metal. With chlorine, they form chlorides. What will happen if non-metals react with hydrogen? See, when metals react with hydrogen, they form hydroxides. And here, when non-metal react with hydrogen, they form covalent hydrides. Look at these examples. When sulfur combines with hydrogen, it results in the formation of hydrogen sulfide. Generally, non-metals do not react with water because the non-metals cannot reduce the hydrogen ions of the water. So that's why they'll not show any reaction with non-metals. But there are certain non-metals which react with water, and those I'll discuss later. So first I'll do reaction of non-metals with hydrogen. So when non-metals react with hydrogen, they form hydrogen sulfide, covalent hydride. So when sulfur react, it forms hydrogen sulfide. When nitrogen react, it forms ammonia. Okay. Then non-metals, as I told you, they do not react with water or steam, and they'll not evolve any hydrogen gas. But if we look at the examples of metals, when they react with water, they result in the formation of hydrogen gas. But non-metals cannot react with water because non-metals cannot reduce hydrogen ions of the water molecules. So that's why they'll not react with water. But there are certain non-metals which react with water, and then they'll release oxygen gas. And examples of such kind of non-metals are fluorine, right here, fluorine. Fluorine is a non-metal which reacts with water to form oxygen gas. It liberates oxygen gas. For example, it's 2F2 plus H2O. It results in the formation of 4HF, which is hydrogen fluoride, plus O2. So it reacts with sulfur, it forms sulfur hydride. It reacts with hydrogen, it forms covalent hydride. It reacts with fluorine, it forms this hydrogen fluoride. Fine. Now, non-metals do not react with dilute acids also. But there are certain non-metals, they react with dilute acid, and examples of such kind of non-metals are sulfur. Like sulfur, when it reacts with H2SO4, it results in the formation of sulfur trioxide and H2O, sulfur dioxide. Okay, so non-metals do not react with dilute acids because non-metals itself are the electron acceptor. So they'll not displace hydrogen from the acid. So that's why they'll not react with dilute acid. But sulfur, when react with acid, it results in the formation of sulfur dioxide and water is released. And sulfur can react with, I'll write one more equation, with HNO3. Now, tell me what is this HNO3? And it results in the formation of H2SO4 plus nitrogen dioxide gas plus H2O. Okay. So these are the two reactions of sulfur. Now write in the comment box what is the name of these acids, HNO3 and H2SO4. Now after this, one more reaction is there before I start with this fourth one. Non-metals, they react with salt solution. And more reactive non-metal displaces the less reactive one. An example of such kind is when non-metal react with salt solution. An example of such kind is sodium bromide plus chlorine, which results in the formation of sodium chloride plus bromine is left behind. Okay. So when non-metals react with salt solution, it results in the formation of salt. And this is the example of non-metal when they react with salt solution. So here also, most reactable species are less reactive. Okay. Then, what will happen if metals react with non-metals? See, if a reaction takes place between metal and non-metal, so it results in the formation of ionic compounds. Whenever any element, whether it is a metal or non-metal, if it want to get stable, it want to exist in nature, it should have its complete balanced electrons. And this tendency of combining capacity entirely depends on the electronic configuration of metals and non-metals. So here, when metals and non-metals, they react with each other, they result in the formation of ionic compounds. Here, ionic compound means they contain ions. So, if any metal wants to be stable in nature, it loses electron. As we know that metals are electropositive ions and non-metals are electronegative ions. So here, metals are losing their electrons and non-metals are gaining electrons to be stable in nature. And this loss or gain of electrons, it results in the formation of ionic compounds. And two charges or two charged particles are present in these metals and non-metals. And those charged particles are known as ions. And positive charged ions are present in ions and we call them cations. And when negative charged ions are present, we call them anions. And once they'll attain, they'll lose or gain electrons, they'll attain, noble gas configuration. They become inert in nature because they'll get stable in nature only when they'll have 2 or 8 electrons in their outermost shell. Either their outermost shell has 2 electrons or 8 electrons. We'll discuss about electronic configuration, how we can write, what are the rules in next chapter. So here or you have studied in your previous classes as well. For example, let's take an example of sodium. Its atomic number is 11. And I want to write its electronic configuration, KLMN. These are the shells of energy, we call them energy shells, in which these electrons are present. So this is the atomic number. Atomic number is equal to number of electrons. So 281 is the electronic configuration. Its outermost shell is M and it has only 1 electron. So what it will do? It will lose its 1 electron or it will take 7 electrons. But the most easy task is to lose 1 electron. So it will lose its electron and it becomes Na positive. So this is cation. It becomes cation. And we'll take an example of chlorine, whose atomic number is 17. I'll write its electronic configuration, which is 287. Now tell me whether it will lose 7 electrons or it will gain 1 electron. Which one is the easier task? Write in the comment box. If you know the answer, please write down which one is the easy task for the chlorine to lose 1 electron, to lose 7 electrons or to gain 1 electron. If you have written, so okay, just check your answer. It is easy for the chlorine to gain 1 electron. So it is accepting electron. This is known as the acceptance. It is taking electron from some outsider. So this acceptance of electron results in the formation of negative ions. And this is known as anion. And these two are known as ions. And after attaining this, now it has 8 and it has also 8. Now they become noble gas in nature. They'll become inert in nature. Okay, so this is how these metals and non-metals react with each other and how do they form the ionic compounds. Let's look at the example. The positive ion, as I told you, if we talk about sodium, so it is here, you can see it is losing one electron, so it becomes positive charge. Similarly, with the case of magnesium, if it lose electron, okay, its atomic number is 12. I'll write its electronic configuration. It has 2, but you'll say, ma'am, you were saying if it has 2 or 8 electrons in its outermost shell, then it is stable in nature. But that 2 electrons should be in K shell only. But here, outermost shell is M. Although it has 2 electrons, but outermost shell is M. So again, it is not stable in nature. So for the stability of magnesium, what it will do? It will lose 2 electrons. And if it is losing 2 electrons, as you can see here, we have written 2E minus. So we can represent losing electrons like this. And it is losing electrons, so it becomes positive, and we have Mg2 plus. Fine. Now let's come to the negative ion. As I told you, negative ions are formed by the acceptance of electrons. So here, chlorine is accepting one electron. Electronic configuration I have already discussed with you. So it is accepting one electron and then it attains chloride. Look at the difference when any particular element is accepting electron. So we'll write E this side, and if any element losing electron, so we'll write element this side because it is losing. Now how these ionic bonds are formed? The ionic bonds are formed between the metals and the non-metals due to the transfer of electrons. Just now I told you, metals and non-metals, if they want to be stable in nature, if they want to exist in nature, either they lose electron or gain electron. Generally, metals lose electrons and non-metals accept electron. And due to this, they'll attain stability in the nature. And due to this losing or accepting electrons, a bond is created between them. And that bond is known as ionic bond. We call it ionic bond. So what we can say that the bond formed between positive and negative ion is known as ionic bond. And the compound which is formed as a result of this ionic bond, it is electrically neutral because it contains positive and negative ions in equal numbers. And that's why they are electrically neutral due to the presence of equal number of positive and negative ions. Now example of such kind of ionic compounds are, first ionic compound is NaCl. NaCl is a salt which we are consuming on a daily basis, which is sodium chloride, or we call it table salt. So this NaCl or table salt, it contains sodium and chlorine, and sodium is a metal and chlorine is a non-metal. So first look at the atomic number of these metal and non-metal. Atomic number of sodium is 11 and its electronic configuration is 281. I have just discussed with you. And number of electrons in the outermost shell is 1. And now look at non-metal, which is chlorine. Atomic number is 17. Its electronic configuration is 287. And electrons in outermost orbit is 7. So here valence electrons are those electrons which they are taking or losing. Those electrons are known as valence electrons, and that process or that is known as losing or gaining of electrons is known as their valence. So here simply valence electrons is 1. But if we talk about in case of chlorine, which has 7 electrons in its outermost shell, these are number of electrons present. This is not the valency of chlorine. The number of electrons it is accepting, that is the valence electron or valency of chlorine. So here it will take 1 electron to get stable in nature. So if it combines with sodium, see how it combines. NaCl. NaCl. Na. So we'll take only outermost electrons. The electrons which are present in outermost shell, or we can represent by X, or you can use any symbol. Outermost electrons in chlorine is 7. So I'll represent these 7 electrons, 3, 4, 5, 6 and 7 by these dots. Now if this sodium gives it or transfer its 1 electron to chlorine, then this sodium also becomes stable and this chlorine also becomes stable. How? Let's see here. If it gives 1 electron, sodium which is 281, if it is giving 1 electron, it has 8 electrons in its outermost shell, it is stable. Let's look at chlorine. And if it will gain 1 electron from this sodium, it becomes 8 and now it is stable in nature. So in this manner, they both are stable in nature, sodium as well as chlorine. So here sodium is transferring its electron and chlorine is accepting electron. So whosoever is giving or donating electron, it attains positive charge, and whosoever is gaining electron, that attains negative charge and will get NaCl. So whenever you are writing formula of any salt, we never write their charges. As you can see, equal number of charges are present on them, and it becomes electrically neutral in nature. So this is how this ionic compound, and this NaCl is known as ionic compound because this is formed by the transfer of ions. That's why we call it ionic compounds. So this is how ionic compounds are formed. Now what are the properties of ionic compounds? These ionic compounds, they are solid in nature, they are crystalline in nature, and but if we break them, if we apply some force on them, they break. Okay, so they are crystalline in nature. These are crystalline. This right here, they are crystalline in nature. What do you mean this term crystalline in nature? See, these are present in the form of crystals. See how these crystals are formed. So it is a combination of sodium. These are sodium and chlorine are present here. So it is present in the form of crystals. And these ionic compounds are solid, but if we apply some force on them, we can break them. And they have a strong bond of force of attraction between them due to this crystalline nature, due to the ions which attract strongly with each other, because positive and negatives, they are opposite charges and they attract each other. So due to the strong force of attraction between these ions, they have a very strong ionic bond between them, and that's the reason they exist in solid in nature. And these ionic compounds are brittle, as I told you. When you apply some external force on them, they break. These ionic compounds, they have high melting and boiling point due to the strong force of attraction between them. Due to this strong force of attraction, they have very high melting and boiling point, because they need very high temperature to overcome these forces of attraction. And they generally dissolve in water, or they dissolve in polar solvent. Polar solvent means water. They dissolve in polar solvent, but they will not dissolve in non-polar solvent or organic solvent like kerosene, benzene, petrol, alcohol. They will not dissolve into it. So, and what is the reason they will dissolve in polar solvent? See, as we see, water is a polar solvent. Due to its polar nature, it has positive and negative ions both. So if we'll take sodium, so due to its polar nature of water, these negative ions of water move towards the, or attract the sodium towards it. Or if we talk about chlorine, so the positive ions of water attract towards the chlorine due to the strong forces of attraction. Now they can easily dissolve in water, and this is due to the polar nature of water. They can easily dissolve in polar solvent, right? Now they not dissolve in organic solvent, because in organic solvent they do not have these kind of polar ions. Both the ions do not present in them, are not present in them. Then ionic compounds do not conduct electricity in solid state. So they will conduct electricity in their molten state, and if they dissolve. So these ionic compounds do not conduct electricity in the solid state, but their solution in molten state they can conduct the electricity. And this is due to the presence of the ions in the solution of the ionic compounds, which allow the electricity to pass through them and to the opposite electrodes. So they conduct electricity in their molten state. And how can you prove that? Let's take an example. Suppose we have this beaker here. Here is the beaker in which we have taken salt solution. You can take any salt solution. Suppose here I have taken NaCl, which is dissolved in water, and it is known as electrolyte. Electrolyte. And here we have taken 2 electrodes. Then we connect them with the battery, and here we have one bulb. Now here we have 2 electrodes. One is cathode and another is anode. So now when we take this salt solution and we connect it with the electric circuit, when we pass electricity through this salt solution, due to the passing of electricity, this salt solution, due to the when the current passes through it, this bulb will glow. And when this glowing of bulb indicates that this salt solution is capable of conducting electricity through it. If you take another solution, like not in case of, for example, if you take NaCl in solid state, don't dissolve in water, just take it as a solid state and then allow the electricity to pass through it. You'll see that the bulb will not glow. So it means the ionic compounds, when they are present in their molten state, they can easily conduct the electricity. So this is how these ionic compounds are capable of conducting electricity. Now, what kind of question can come on the basis of this topic? What are ionic compounds? List some properties of ionic compounds, or why ionic compounds can conduct electricity. It is due to the presence of ions in their solution. They'll be able to produce they'll allow the electricity to pass through them or conduct electricity through them. Let's take one more example of ionic compound, like magnesium chloride, MgCl2. Or MgO2, magnesium oxide, MgO. Now tell me how this ionic compound is formed in magnesium oxide. If you know the answer, please write down in the comment box. Magnesium, its atomic number is 12. And just write, first I'll write electronic configuration, which is 2A2. I'll represent, and oxygen 2 and 6. Its atomic number is 8. So in outermost shell, it has 2 valence electrons and it has 6 valence electrons. It needs 2 electrons and it loses 2 electrons. Magnesium is a metal and oxygen is a non-metal. So see how this ionic compound is formed. I'll write these 2 electrons, or I'll represent by these crosses. On oxygen, it has 6 electrons, valence electrons in its outermost shell. So I'll represent it by these dots. And if it transfers its 2 electrons, then it becomes Mg2 positive and O2 negative. O2 negative. Or we can represent like this, Mg this one, or oxygen this. Okay. Or we can write Mg2. And as I told you, when we are writing this chemical formula, we never write down charges. So 2 and 2, as you can see, 2 and 2. So they are equivalent, equal number of positive and the negative charges. So they are equal, which makes this salt electrically neutral in nature. So I hope till here it is clear to you, and try to do these ionic compound formation of ionic compounds and practice few questions on this topic, how these ionic compounds are formed. Generally these type of questions come in exam in 2 marks. So write down the ionic compound formation of a particular salt they'll give you, and then you have to solve it like this, and you have to make ionic compounds in this manner by showing this. So here you can see magnesium has 2, oxygen has 2, and they are equal, positive and negative, they both are equal. So it becomes electrically neutral, and the formula is MgO. Fine. So this is how these ionic compounds are formed. So children, please revise these ionic compounds, their properties, their formation and chemical properties of nonmetals. So whatever exceptions I have discussed with you when I was explaining chemical properties of nonmetals, just go through it. These topics come generally in reasoning